Hey guys! Welcome back to my channel. So for my third vlog, I will be discussing to you the basic operations and applications of 2-input exclusive OR gate, also known as the XOR gate, and the 2-input exclusive NOR gate, also known as the XNOR gate. The operations of the XOR gate or the 2-input exclusive OR gate is like a comparator circuit that compares its input bits. Thus, its logical output is 0 if both the input bits are alike and 1 if both the input bits are not alike. On the other hand, the operations of the XNOR gate or the 2-input exclusive NOR gate performs logical equality. Thus, its logical output is the complement of XOR gate operations, having an output of 1 if both inputs are alike and an output of 0 if both inputs are not alike. This is because of the bubble affix in its output side, which serves as an inverter. In this experiment, we will be using the following materials: 7486 quadruple 2-input exclusive OR gate, 7408 AND gate, 74266 quadruple 2-input exclusive NOR gate, LED, 360 ohm resistor, breadboard, 5 volts power supply, 12 volts power supply, relay, 1N4001 diode, 2N3904 transistor, 12V DC motor, connecting wires, and alligator clips. For the first part, entitled Examining the Basic Operations of an XOR Gate, we will be following the diagram shown in order for us to build the circuit. It can be seen in the data gathered that the output will only have a value of 1 if at least one of the inputs has a value of 1. This is because in an XOR gate, the output is logic 1 whenever the inputs are not alike and an output of 0 whenever they are alike. The second part is all about the basic operations of a XNOR gate. The diagram shown will now serve as our guide for us to build the circuit. In the data gathered, it can be seen that there will only be an output of 1 whenever both the inputs have values of 0 and whenever both inputs have values of 1. This is because the logic output of a XNOR gate is the complement of the XORs. Thus, an output of 1 is observed whenever its inputs are alike and 0 if not. Proceeding to the third part of the experiment, we will be building a circuit that shows a single direction DC motor control. And for us to build it, we shall make use of the diagram shown to serve as our guide. can see in the table that the output for this part is the same as of the first part. This is because they both make use of the 7486 quadruple 2-input exclusive OR gate. Thus, an output of 1 is observed if both inputs are not alike and 0 if they are alike. For this experiment's last part, we will be constructing a circuit entitled half adder. This will be done by following the diagram shown. The table for this part shows that we have two outputs, namely the sum, which is represented by the letter S, and the carry, which is represented by the letter C. Both outputs S and C have values of 0 if both inputs are 0. Output S is then observed to have a value of 1 whenever the two inputs are not alike, and a value of 1 for the output C whenever both inputs have values of 1. This is because the S output is the output of the XOR gate and the C output is the output of the AND gate. This explains why the S output has a value of 1 whenever the two inputs are not alike, and why the C output has a value of 1 only when the two inputs have values of 1.
That's all for today, guys. I hope you learned and understood something about the two-input exclusive OR and NOR gates in this experiment. See you again on my next vlog. Bye!